let's take a look at these problems that are helping us deal with imaginary numbers and roots. So remember, when we're dealing with radicals and the numbers underneath are negative, that's when we're going to have to deal with these imaginary numbers. Okay? But you got to remember, it depends on the root. Because if I have an odd root, like the cube root or the fifth root, the negative number doesn't matter. So it's just these even roots. And typically we deal with just the square root. So, how do we deal with these? Well, first thing we do is we separate them. Negative 1 times the square root of 25, because we know the square root of 25, right? That one would be 5 times the square root of negative 1, and that square root of negative 1 is what we've referred to as I. So I just write 5I. That would be the way I'd simplify that. So we don't like writing the negative square root of something, we just turn it into I. So if we look at number 2, square root of 36 times square root of negative 1, we know that that is 6, and square root of negative 1 will give us I, so 6I. And remember, whenever we're taking a square root, we have to think plus or negative, right? So technically I should have done that, because I know that negative 6 squared is 36, and positive 6 squared is also 36. So we have to think in terms of both. Okay, number 3 should know that this one's plus or minus 12, and then we deal with that negative with the I. Now, if we look at the last ones, you should notice they're not perfect squares. Okay, so they're not like 25, 36, 144. So to deal with this, we need to simplify. So get rid of the negative 1 first, because we know that that's got to be dealt with. Then we just start to get it down to the factors. So 98 would be what? 2 and 46. 46 would be 2 and 23. Can we take that one further anywhere? I'm not thinking so. And yeah, probably looking, this didn't look right. Knew there was a mistake somewhere. 49, which would be 7 times 7. Okay, so basically this is what we've got, right? We've got the square root of negative 1 times 2 times 7 times 7. And in the square root, we look for sets of 2. So I've got 2 7s, so I know that we'll pull one out, kill the other one. I also know the square root of 1 is going to be I. So I'm going to have 7 times I times the square root of 2. So you'd write that 7I root 2. The I goes in front of the square root. Okay, so 52, same idea, negative 1 and 52. See if I can actually get this one right. 2 and 26. There we go. This one would be what? 2 and 13. So it would be square root of negative 1 times 2 times 2 times 13. So I've got a pair right there. Destroy one, pull the other one out. I know that square root of 1 is going to be I, and then I'm left with square root of 13 for my answer. Okay, number 6, 22, negative 1 first, then 2 and 11. So there's nothing else I can do, is there, other than remove the negative, and so have I root 22. Alright, now, when we're dealing with these i's and regular numbers, we call these complex numbers, right? When we have a regular number plus something I. Okay, so we've got the two pieces, the imaginary piece and the real piece. And we call those complex numbers. Well, when we deal with I, typically we treat it like a variable. Okay, so like on number 1, think of that as 10 minus x plus 3 minus 6x. How would we deal with that? 10 and 3 would give us 13. Negative x and negative 6x would give us negative 7x. And that's as simple as it gets. Well, with number 1, we do the same thing with I. Okay, put those together, that gives me 13 minus negative 1i and negative 6i, negative 7i. See the similarity? There's going to be one difference, and that's when we get down to the multiplication. But for the addition and subtraction, we just leave it like that. That's as simple as we can get it. So if I look at number 2, I distribute the negative, so I've really got 9 plus 6i minus 4 plus 4i. So combine the regular numbers. 9 minus 4 is 5. 6 plus 4 gives me 10i. Okay, number 3, same thing. Doesn't matter how many we have, we just treat it the same. The negatives would give me 4i minus 7 plus 5i plus 10 minus 7i. So negative 7, positive 10 would give me 3. 4 and 5 would give me 9i. Minus 7 would give me positive 2i. Okay? Let's clear those ones. Now number 4, 7 plus negative 4 plus 8i. That minus distributes, so plus 10 minus 2i. So combine the i's. Positive 8, negative 2, positive 6i. 7 minus 4 would be 3, plus 10 would be 13, plus 6i. Okay, now with multiplication, we still kind of treat it the same way. So, except for one instance, which we'll see in number 6. So 5 times 8, negative 5 times 8 is negative 40. Negative 5 times negative 2, positive 10i. However, on 6, we've got negative 11i times negative 2 minus 9i. So treat it just like a variable. So that would be positive 22i. Then negative 11 times negative 9 would be positive 99. But then I times I would give us I squared. Now, here's where we have to remember that I is the square root of negative 1. So if I square both of these to get I squared, the square and the square root cancel out and we're left with negative 1. Okay? So I squared turns into negative 1, so it's 22i plus 99 times negative 1, so it's negative 99 plus 22i, because we put the regular number first. So that's our answer for number 6, because of that I squared. So that's what you got to look out for. Okay, so 7, 9 times I is 9i, 15i times I is I squared. That I squared makes 15 negative, so we get negative 15 plus 9i. Okay, number 8, now we're going to deal with two binomials essentially. Okay, so this is FOIL, or just each of these pieces have to multiply by each of those. So negative 6 and 4, negative 24, negative 6 and negative 12, positive 72i, negative 7 and 4, negative 28i, negative 7 and negative 12, positive 84i squared. That I squared makes that 84 negative. Then we combine like terms. Negative 24, negative 84 would give us negative 108. Then combine those like terms. 72 minus 28. .44. So plus 44i. So there's our answer to number 8. Kind of a long one, but okay. Now number 9, same idea. So you can kind of see the same thing you're going to end up with. So negative 14, positive 10i, positive 7i, which those two would combine, right? 17i. Then I know that last term, even though it has i's in it, because it's squared, that's going to turn into negative 1, which turns us into positive 5. Negative 14 plus 5 is a negative 9. So negative 9 plus 7i. So we're still able to simplify it and get it down to just a binomial style. That was number 9. Okay, number 10. 1 and 12 are 12. 1 and 11i, 11i, 4i and 12, 48i, 4i and 11i, 44i squared. So that's really negative 44 and positive 12 would be negative 32 plus 59i. There's 10. Okay, 11, negative 10 and negative 7, positive 70, minus negative 10 and 5, 50i, plus 28i, minus 20i squared. So I squared and that negative make that positive 20. 20 and 70 give us 90, minus 50 and 28 give us 22i. Alright, then the last one, negative 10 and negative 10, positive 100, negative 10, negative 2, positive 20i, 2 and negative 10, minus 20i, 2 and negative 2 will give us a negative 4i squared. Well, positive 20, negative 20, those cancel out. That becomes negative 1, which makes that a positive 4. 100 plus 4 gives us our final answer of 104. And we are done.